Alright guys, so we're going to be looking at this foldable that you got after class yesterday. Make sure you have it out. The first one we're going to be looking at is the multiplying powers with the same base. You're just going to add the exponent. So an example of this would be if we have a squared times a to the fourth. This is the same thing as saying a squared, and then that squared is plus a 4. 2 plus 4 is 6, so it's just the same as a to the 6th power. And I can prove that to you by saying a times, those are the a squareds, times a times a times a times a to the 4th. 1, 2, 3, 4, 5, 6. That's the same as a to the 6th power. If we're going to use numbers, we can have 4 squared times 4 to the 6th. 4, 2 plus 6 is just 4 to the 8th power. That's all we have to do when we have multiplying powers with the same base. Then we have a power of a product. And power of a product is basically, I'm going to change the color so you can see I'm talking about something different now. When we have something like a squared, and then that whole thing is to the 4th power. So we're going to multiply our exponents. We're going to say it's the same as saying a squared, and then that squared is times a 4, or a to the 8th. I can show you this if we have a squared, and then we have 4 groups of that. We're going to add our exponents, 2, 4, 6, 8. It's the same as a to the 8th power. With numbers, this would look like 2 to the 3rd to the 4th, or 2, 3 times 4, 2 to the 12th power. These are all equivalent. Moving further down, now we see something called negative exponents. You guys did negative exponents last year with power of 10. You may or may not remember. But basically, if we have, we're going to change the sign and use the reciprocal. So let's change our color there. A to the negative 4th will simply, we're going to take the reciprocal 1 over a, and that'll be to the 4th power. Cross the line, change the sign. If we have 1 over 3 to the negative 2, that becomes 3 squared. Negative exponents are not allowed in simplified answers. This is not a simplified answer. This is the answer we're looking for. And the last one, fractional exponents. If you have something like a to the 1/2, that simply becomes the square root of a. The numerator stays with the a inside the radicand, and the index is the denominator. In this, we're also going to write down, on the outside, we're going to write rationalizing, R-A-T-I, a denominator. And I'm going to go over this with you in class when I get back, but I want you to take down the notes right now. We're going to start with something that looks like the square root of 26/8. We can have a fraction, so we're going to write something equivalent to that, which is the square root of 26 over the square root of 8. Now, we can't have a square root in our denominator, so we have to multiply it by the square root of 8 over the square root of 8. Now, the square root of 8 over the square root of 8 is the same thing as 1, so we're not changing our value, we're just changing how it looks. 26 times 8 is 208, so now we have the square root of 208 over the square root of 8 times the square root of 8, which is just 8. If you don't believe me, check it in your calculator. Now, we know how to simplify a radical. 208 is just 16 and 13. 16 becomes 4 and 4, so we have 4 square root of 13 over 8. And we can simplify 4 over 8 to be square root of 13 over 2. And again, I'll go over this more with you when I'm back in class on Friday. Don't worry. On the other side, dividing powers with the same base. When we multiply powers with the same base, we added them. So dividing powers, we're just going to subtract our exponents. If we have a to the fourth over a squared, that simply becomes a to the fourth minus 2, or a squared. With numbers, 4 to the 6 over 4, there's an understood 1 right here. So 4, 6 minus 1, 4 to the 5th power. And if you want me to show you a times a times a times a over a times a, those cancel. We're left with a squared. Power of a quotient. When we have the power of a quotient, it's going to look like a squared over b, and we're going to take that whole thing to a power, to the 4th power. We're going to distribute our 4 to both of our parts. A squared to the 4th power is a to the 8th power. B to the 4th power is just b to the 4th power. And since our bases aren't the same, that's as far as we can go. If you want to look at it, if we have a squared over b 4 times, a squared over b, a squared over b, a squared over b, 2, 4, 6, 8, a to the 8th over 1, 2, 3, 4, b to the 4th power. And if you want to do it with numbers, 1/2 to the 3rd power, 1 to the 3rd over 2 to the 3rd, or 1 to 2 to the 3rd. You don't have to write 2 to the 8th, or I'm sorry, that's not an 8, that's a 3. You don't have to write 1 over 8 unless it says without exponents. You can just leave it like that. 0 power. Anything to a 0 power is 1. 10 to the 0 power is 1. A to the 0 power is 1. And the last thing, we don't really have to write anything. Parentheses placement. It's very important that we notice that -2, in parentheses to the 4th, is not the same as -2 to the 4th. And I showed you right here. -2 times -2 times -2 times -2 is not the same as -1 times 2 times 2 times 2 times 2. We just have to be careful.